In this video, you will learn how to solve different problems in trigonometric functions. So let's solve some sample problems here. A surveyor wants to find the distance across a swamp. So we're given here this figure, and the bearing from A to B is 32 degrees northwest, and the surveyor walks 50 meters from A, and at the point C the bearing to B is 68 degrees northwest. We find the bearing from A to C and the distance from A to B. So we need to find this distance from A to B and the bearing from A to C. So this angle here. Okay, when we say bearing is the angle formed by the reference line and the meridian. So what is meridian and the reference line? So the reference line here in this problem, it's already given, point A to point B, and the meridian is the imaginary line that we're going to draw, imaginary line of longitude on the earth that extend from north to south pole. So it's basically a vertical line. Now to solve this problem, we just have to visualize everything, or analyze everything first. See, let's draw our reference here first. So this is north, south, east, and west. So this forms a triangle here. Let's just extend our drawing. So let's say this is our triangle. This is point A, this is point B, and then this is point C. And it is given here that the bearing from point A to B is 32 degrees. Let's draw our meridian here. Our reference line is side AB. So that means this is 32 degrees. And it is given that this is 90. This one is 90. Then this angle here is just equal to 90 minus 32. So this is 58 degrees. And it's also given here that the bearing from point C to B, so from this point to this point, the angle formed. So let's draw a vertical line here, or dash, as our meridian. So the angle, or the bearing from point C to B is 68 degrees. Okay, by the way, the bearing, our answer for the first question, find the bearing from A to C. The bearing from A to C is just 58 degrees. This one. So that is just 58 degrees northeast. Now, to find the distance from A to B, to answer the second question, okay, this one here, we can use tangent functions, but first we need to find angle C first. Okay. Okay, so we already got this angle here. Angle, let's say this is point D, angle DAC, which is 58 degrees. And we need to find this angle to solve for angle C. So this angle is just equal to 58 degrees, since this angle and this angle are alternating angles. So if this is 58 degrees and this is 68 and this is a straight line, so that means angle C is just equal to 180 minus 68 minus 58 degrees. So angle C is just equal to 54 degrees. So this one is 54. Now we already have the measure of angle C, then we can solve for the distance from A to B. So this is 54 degrees, this is 90, and this is point A, point B, point C, and we need to solve for this. Okay, forgot this is 50 meters here. Now we can solve for angle C. So that would be tangent of angle C is just equal to opposite. Let's say the opposite side is small c, opposite over adjacent side, which is 50 meters. And angle C, we got 54 degrees. So tangent of 54 degrees equals C over 50. C is just our AB, side AB. And now to calculate for C, we just multiply 50 and tangent 54 degrees. Therefore C, which is just our segment AB or side AB, is just equal to 68.82 meters. So this is the distance from A to B. So this is 68.82 and C here is 54 degrees. Let's solve another problem. Okay. A plane is observed approaching your home, and you assume that its speed is 550 miles per hour. The angle of elevation of the plane is 16 degrees at one time and 57 degrees 1 minute later. Approximate the altitude of the plane. Now to solve this, we need to visualize the plane and its altitude. So we draw. Okay, but before that, let's convert this one 550 miles per hour to 2 miles per minute, because it is stated here the plane's elevation is 57 degrees 1 minute later. So that would be 550 miles per hour. We convert to minutes, so we divide this by 60 minutes, because there are 60 minutes in 1 hour. Okay, then we reduce this. This is just equal to 55 over 6 miles per minute. Yes, 55 over 6 miles per minute. And now let's draw. Alright, so if this is our ground, right, it says here that the angle elevation of the plane is 16 degrees at one time. So okay, let's say this is our plane here. So its angle of elevation at one time is 16 degrees. So it creates an altitude of, let's say, the distance from the ground to the plane is h, and then at 1 minute later, its angle of elevation is 57 degrees. So let's draw another angle 1 minute later. So this is 57 degrees. So the plane is here. So the same altitude. So that is also h. So let's say this is point A. Okay, point B, point C, point D, and point E. Okay, it is stated here in the problem that the angle of elevation changes from 16 degrees to 57 degrees. So the plane, after 1 minute, traveled a distance from this point here, point B, to point D, or from point D to point B. So the plane traveled over the distance BD. So we already knew the speed of the plane, which is 55 over 6 miles per minute. Then we can calculate the distance BD by using the speed distance time equation. So using the formula of the speed, which is just distance over time, to solve for the distance, that is just speed times time. So our time is 1 minute. So the speed is just 55 over 6 miles per minute times 1 minute. This cancels out. So the distance between B and D is just 55.6 miles. So this is 55.6 miles. We don't know this distance from point A to point B. So let's say this is X. Okay, now we already have the value of the distance from A to B and then from A to D. So we can use the tangent function here. So distance from A to B, this is just X, and distance from A to D is X plus 55 over 6. Now to solve for the altitude, okay, we just get the tangent of the angles, each of the angles 16 degrees and 57 degrees. So that will be tangent 16 degrees is equal to the opposite side, h over adjacent, which is x plus 55 over 6. And then the other one is tangent of 57 degrees equals h over x, distance from point A to point B. And now we can solve for h. Okay. H is just equal to x plus 55 over 6 tangent 16. Then the other one is h equals x tangent 57 degrees. And we just have to equate them. So this would be x plus 55 over 6 tangent 16 degrees equals x tangent 57 degrees, and then distribute tangent 16 here. So this would be x tangent 16 degrees plus 55 over 6 tangent 16 degrees equals x tangent 57 degrees. And then we group like terms, so we can group this one, x tangent 16 and x tangent 57 degrees. So that would be x tangent 16 degrees minus x tangent 57 degrees equals, we transpose 55 over 6 tangent 16 to the right, that would become negative 55 over 6 tangent 16 degrees. Okay. And then we factor out x, so we have x times tangent 16 degrees minus tangent 57 degrees equals negative 55.6 tangent 16 degrees. And we divide both sides by, okay, let's just delete this. So we divide both sides by tangent 16 minus tangent 57. So this is x tangent 16 degrees minus tangent 57 degrees equals negative 55 over 6 tangent 16 degrees. We divide both sides by tangent 16 degrees minus tangent 57. This cancels out, so our x is just negative 55.6 tangent 16 degrees over tangent 16 degrees minus tangent 57 degrees. All right. Using the calculator, 55.6, that is 9.17 times negative 9.17 times tangent 16. So that would give us negative 2.63 over tangent 16 minus tangent 57. This is negative 1.25. Therefore, x is just 2.63 divided by 1.25. So this is 2.1 miles. Now we have the value of x, so we can plug in to that equation that has an elevation of 57 degrees. Because I already deleted it, I'll just write it again here. So h equals x tangent 57 degrees, and the other one is h equals x plus 55 over 6 tangent 16 degrees. So we plug in this one, value of x, to the angle elevation 57 degrees. So our altitude is just 2.1 miles tangent 57 degrees, and this is just equal to 3.23 miles. So this is the altitude of the plane.